For today's notes, we are solving exponential equations where the base is not the same on the left or right hand side, so you have to find a way to get the bases to become the same. So in other words, when we look at this question right here, we have 6 is a low number for the base. Is there a way to get 36 to become 6 raised to a power? Well, we know that 6 squared is 36, so we're going to deal with that. So we're going to substitute, instead of saying 36, we're going to say 6 raised to the 2x minus 10 power is equal to 6 squared, because 6 squared is 36. Then we answer the question like we did before. The 6's go away. You set the equal signs up there, and we have 2x minus 10 is equal to 2. I'm going to add 10 to both sides. It gets me 2x is equal to 12. X is equal to 6. Let me go ahead and plug it back in. 2 times 6 is 12, minus 10 is 2, so that gives me 6 squared is 36. It checks out. Number 7, it says 7 raised to the 4x plus 11 power is equal to 1 over 7. We have 7s. However, this is a fraction. So if we wanted to make the 7 the same base as the 7 over here, we can rewrite this 1/7 to be 7 to the negative 1 power. When you raise something to the negative 1 power, you take the reciprocal. That means that the bottom or the denominator of this fraction comes up, and we change the 7 to a negative 1. Now we can work with this question much easier. This is 7 raised to the 4x plus 11 power is equal to 7 to the negative 1 power. Now that our 7's are the same, the bases are the same on both sides, we cross them out, set them equal to each other. I have 4x plus 11 equals negative 1. We subtract 11 on both sides, and that gets me 4x is equal to negative 12. X is equal to negative 3. So we check our work. 4 times negative 3 is negative 12 plus 11 is negative 1. So 7 raised to the negative 1 power is equal to 1/7, as shown above right here. So we know that that answer works out. Then the last question, we have a 27 over here, and we have a small base of 3 over here. So the job is to try to figure out what can I get 3 raised to what power can give me 27. So I know that 3 squared is 9. 3 to the 3rd power is 27. 3 times 3 is 9 times 3, 27. That's what we want. So because we're changing 27, 27 is equal to 3 to the 3rd power. We're going to put that in right here. So that's 3 cubed, and that's being raised to the 2x plus 6 power is equal to 3 raised to the 2x power. We have to remember our laws of exponents. We must distribute this 3rd power to the 2x plus 6, giving me 3 raised to the 6x plus 18 is equal to 3 raised to the 2x power. I'm going to go ahead and get rid of the bases because they're the same on both sides now. And I have 6x plus 18 is equal to 2x. I'm going to go ahead and solve that. That's going to give me 4x. On the left side is equal to negative 18. I divide by 4. And I get x is equal to negative 9 over 2. So if I plug in negative 9 over 2 right here, this gets me negative 9 plus 6. Which is negative 3. And then here, if I put in, this will give me 3 to the negative 9 power. So that will end up working out because 27 is 3. And if I multiply that by the negative 9 over 2, it will check out and work. I just don't have enough space to write it out. That takes care of questions 5, 7, and 9. The first question, 5, was x equals 6. Number 7, x equals negative 3. And number 9 was closed off at the end. I solved the question, plugged it in, came out with the right answer, and that takes care of our solving exponential equations with common bases, without a common base.